Well, good morning, and thank you for joining us. Really had a good time so far listening to all the good information that's coming out. For those of you that may just be joining us, depending on how you might be handling the virtual meeting, I want to remind folks that if you are just joining us and you're looking for appropriate credit or PDHs, we do need you to log in individually. That's how we are going to provide the PDHs or otherwise credit if you need it that way. So if you're in a group setting, I need you to somebody get out of that, log in, so we got a formal record of that, and go to the registration page. You need to register also. So with that, I'm here to present our poster section and our poster competition that we have as part of our Transportation Research Day here. It's something that's been going on for many years, and it's developed and gotten better and better and better. And I always wish I had more time to talk to the folks in person, but I'm really excited about what we were able to put together this year with the virtual environment. And that as we are getting better at this, hopefully we're also getting better about being able to provide the follow-up and further collaboration beyond just today's meeting. So with that, I'm going to share my screen, and we will start with presentation. I apologize. Let me get on the right screen. All right, so very good. I am David Ooten, head of the Office of Research and Implementation for ODOT. And this year we had 42 posters submitted. A lot of our partners with SPTC and in and around the folks that we work with provided input. Got one from up in South Dakota. Thank you for that. We would love to turn this into always as big as we can get. We'd love to have you. We're very excited of the efforts and the work that goes into this. No easy task to put some of these things together, because part of what we do is we ask for an abstract, and we also ask for a 3-minute video. We'll be talking about that and showing some of those here in a few minutes. So I want to say thank you to everyone who put those things together in the time, not just on the students' part, but all the collaborators within an individual project or the professors as well. No easy task, again, to put these things together. We broke our posters down this year by category, hopefully trying to make it a little easier on ourselves, and hopefully easier on those that are in attendance with us or want to join us, in this case, maybe post-meeting, depending on how we handle the virtual situation. But I was very excited to see that we had a nice breadth across the board of the different topics that we deal with. So often we know a lot of times we're in the brick and mortar kind of phase of what we do, but we also know the transportation, is broad and it's far reaching, and we do get into some other areas that not everybody understands or really knows about. They don't always understand the importance of the various phases of things that we do. So I'm always excited to see some of the, I'll call them non-traditional areas being explored and looked at. Of course, we all drive some sort of vehicle, automated, connected, or otherwise. So we're obviously concerned about our bridge structures and our asphalt and our paving situations. But again, we know in this community that it all goes in together. At the bottom, and this is referenced in the program, and I'll talk a little bit more about this in a bit. This is the link to all of our posters. This is on page 9 of our program, and if you go to that page, you'll see the breakdown is noted here, and then you'll see links to abstracts, posters, and then videos as they're available. And I don't think we have video necessarily on every single poster, but darn near every poster we have a video, and then you should get a lot of information that way. So I wanted to just take a little time with the captive audience. Even though I'm sure anybody that was here for an earlier break did not run around the corner did not go to get some more coffee, did not go to get another donut. I'm sure they went to look and see all the posters, but no, I know it's tough. But I want to provide this opportunity to at least present the titles that we have within these different areas, give you just a quick glance. I know you're not going to take every single one of these in, but just get a little feel for the different topics and the subjects. Being asphalt materials, we had 10 of these. And here's our bridge topics. Again, covering a lot of different issues within structures. And like I said, hoping just to scan through the titles just a little bit. I know you can go there later, but I also know what it's like sometimes if we, yeah, I'm going to get there later, and you want to go to the program, an email's coming in or something. So yes, I'm taking advantage of a little bit of a captive audience. So thank you for bearing with me and hanging in there with me. Concrete materials. Some on those. Roll over here into geotech. Some titles there. Machine learning, traffic, and safety. We heard a question involving machine learning this morning. One of those other disciplines that was noted this morning about our industry in our world. We are not one-faceted, we are multifaceted. And as with so many other industries, a lot going on there with AI and machine learning and other such things. Obviously, traffic and safety being a paramount issue for all of us. And then with pavements and other infrastructure. And so I would like to, at this time, recognize our judges. Always appreciate the time that these folks spend on what they're doing to help OTRD and make it a good event, a great event. Each judge reviewed every poster, reviewed every abstract, reviewed every video. On average, the numbers that we were given was roughly 10 hours. 10 hours of their personal time to help us out with this. I know that's no easy task, but to Mr. Burwell, Mr. Gutierrez, Mr. Peters, Mr. Sider, and Mr. Suter, thank you. At some point, not enough, but truly, if we get the chance to get back together, we'll buy you 2 lunches next time when we have a chance to maybe meet in person. But again, we want to thank you very much for your help with this event. Hard to see, I know it's a little bit small, but I wanted to provide the evaluation form that we use so everybody kind of had a feel of the things that we were looking for and what we did there. And so it helps the contestants, it helps the folks that prepared the posters, and maybe gives others that are just watching this kind of know the things that we were looking at and how we judged to get to where we're going to give out a few awards here in just a bit. So we do have part of this is for knowledge, and when we have a chance to meet in person, I truly do not have enough time in the day to do what I really personally would like to do. And I like to walk around and talk. I like to talk to everybody that puts something out there. There's so much knowledge to be gained and so many things to be learned. But we know there's just not enough time. But we also know we have a lot of good quality work going on in our midst. Obviously at our state schools, but obviously our partner schools. And so we're obviously excited, as I said earlier, to have those folks join us. But we have a competition, and we'd like to recognize those folks that were definitely exceptional. And they were all great posters. But we came down to having the competition. So we're going to start with second honorable mention. Goes to the team from Missouri University of Science Technology on the repair of corroded steel bridge columns using ultra high performance concrete and experimental study. And so what we want to do during this phase of this session this time is I'm going to pull up the videos, and we're going to look at the videos that were recognized from our competition committee.
Hi, my name is Binod Shrestha, and I'm doing PhD in Missouri University of Science and Technology. First of all, I would like to thank the organizing committee for providing us this opportunity to share and talk about our research work in front of all of you. My research work is about the repair of corroded steel bridge column using ultra-high performance concrete. Many existing bridges in the United States are structurally deficient, and in Missouri alone there are more than 3,000 structurally deficient bridges. One of the reasons is moderate to severe corrosion. Because of this, there is a reduction in overall load carrying capacity of the bridges. So there is an urgent need for the repair. This project focuses on the main objective of using UHPC as a repair material, and then recommending the Department of Transportation a composite repair system. So the experimental work is divided into two phases. In first phase, different parametric studies using UHPC thickness and configuration, carbon fiber polymer grade layer, and size of shear connectors were carried out. In total, 12 steel H-piles were subjected under push-out test. And from the experimental result, it is shown that increasing the UHPC thickness, increasing the diameter of the shear connectors, and adding the CFRP grade layer increase the axial capacity. And in second phase, the best composite system using the UHPC in terms of axial capacity achieved in phase 1 were used to repair the 3 deformed corroded steel H-pile under compression load. So the deformed steel H-piles were first straightened, and then the UHPC plates were mounted on the steel H-pile using the shear connectors. And under the compression load, the corroded steel H-piles repaired with UHPC plates showed an increment of about 125% of the axial capacity compared to the unrepaired original strength. So from this, we can recommend a UHPC plate as one of the repair system for the corroded steel H-piles. So finally, I would like to thank our sponsor, the America Transportation Center, Missouri Department of Transportation, and Nuclear Skyline for supporting our research. And also I would like to thank the Missouri University of Technology. Thank you.
Well done, well done. All right, we're going to move on to our first honorable mention place, and the honorable mentions will receive a certificate from us. Louisiana Tech University, their research team on the development and validation of a polystyrene functional group-based mixed index to predict the SPS content using a handheld FTIR spectrometer. I love saying those titles. Let's take a listen to this one.
Hello. This study is based on the determination of S-base content in S-base modified asphalt binder using a universal model. That means no calibration curve will be needed to predict the S-base content. The challenges in quality control of S-base modified asphalt binder during construction are segregation and thermal decomposition. These two can lead to poor rutting performance at high temperature and poor cracking resistance at low temperature. For the quality assurance purpose, S-base content needs to be determined. AASHTO has a standard for S-base content determination in S-base modified asphalt binder and immersion. But this standard requires to build calibration curve for all specific binder. The goal of this study is to develop a polystyrene model using peak height method at the web number 699 and to develop a polybutadiene model according to the AASHTO standard. For this purpose, 3 different PG binders from three different sources are collected to mix with 3 different types of SBS polymer from 2 different sources. Sulfur was added in SBS modified binder as a cross-linking agent. SBS polymer was added in the binder at the laboratory using a high shear mixture. The height of the functional group was determined by drawing a baseline considering 2 lowest points on either side of the characteristic functional group. After that, the midpoint of the baseline and top point of the peak was added to determine the peak height. The absorbance area was calculated by the trapezoidal rule model. The baseline was drawn following the similar process as the peak height method. It was observed that peak absorbance height and area are linearly correlated with the SBS content. From the linear regression analysis, 4 models were developed considering outlier data points. ANOVA was performed to check the models statistically. To verify the models, 1 refinery was visited and 2 SBS modified binders were collected. Also, 9 SBS modified binders are supplied from 2 different refineries with unknown SBS content. Using the models, SBS content was predicted and verified with the refinery. It was found that predicted SBS content from the polystyrene model 1 has the highest correlation with the actual SBS content. From the case test, the lowest d-value and highest p-value are obtained from the predicted result using the polystyrene model 1. Finally, it can be concluded that developed polystyrene model can be used to successfully predict the SBS content without any calibration curve. We would like to thank LTRC for funding this study.
Nice job on that. Okay, so 3rd place, 2nd place, and 1st place upcoming. These do involve some cash awards. We will be sending these through the mail. I'm not going to make you drive here to get them, obviously, with the conditions we got going on. 3rd place award winner from the University of New Mexico. Comprehensive evaluation of running of warm mix asphalt utilizing long-term pavement performance specific pavement studies. A very interesting topic. We've been involved with that program for a long time. Let's take a look and listen.
Hello everybody, and welcome to my presentation on comprehensive evaluation of routing of warm mix asphalt utilizing long-term pavement performance LTPP specific pavement studies. So let me go through my work. I'm zooming a little bit. So warm mix asphalt, we all know, it's an asphalt technology that allows lower mixing and compaction temperature in comparison to regular hot mix. So how it does? So it typically softens the binder, so the binder becomes less viscous or more workable, so it has higher workability. And due to the lower production temperatures, it has less initial edging and lower initial stiffness. So the routing performance of the warm mix asphalt is a big concern for the warm mix asphalt technology, since routing is directly related with the stiffness and the aging and all the softening behavior of the mixtures. Here I took the LTPP SPS 10 section, which is located in Interstate 40 in New Mexico, and this sections has 5 different mixtures, including 4 WMA and 1 HMA for the comparison, and 4 WMA includes 1 foaming, 1 evotherm, and 1 segabase with polymer and 1 segabase with non-polymer binder. The method includes lab and field investigation. In lab, I conducted empirical tracking test data analysis. I developed and I used a very advanced method of empirical tracking test data analysis for better evaluation of the routing characteristics based on viscoplastic strain increment. And here I have analysis all the strain analysis and the viscoplastic strain increment and the routing potential. And regarding the field investigation, I use MedVis pavement profile scanner for evaluating the phase measurements from the pavement, and I developed 1 parameter called individual distress index, and that combines all the extent and the severity of the mixtures of the sections and for any particular damages or any distresses. And I compared all the lab routing potential, field rod depth, and also the routing distress indexes for better evaluation of the routing behavior. And based on the analysis, I found several key findings regarding the routing. Firstly, warm mix asphalt with foaming silicaves and evotherm exhibits slightly higher routing than regular HMA. And the field route is mostly equivalent among all this warm mix and the hot mix asphalt, and it shows less than 5 mm for all the sections. The proposed HWT test data analysis better evaluates the routing and moisture damage characteristics. And finally, the PG Plus binder, or the polymer modified binder uses in warm mix asphalt, results in significant improvement in routing characteristics. And that's all about the findings. And I would like to thank University of New Mexico School of Engineering and the New Mexico Department of Transportation for their great support in this research. Thank you.
Move on now to our, excuse me, second place winner from Oklahoma State. Research team and their project utilizing pavement friction data for the reduction of traffic crashes and delays.
Hello, ladies and gentlemen. I'm Wenyao Liu from OSU, the PhD student of Dr. Joshua Lee. I'd like to introduce our study on utilizing pavement friction data for the reduction of traffic crashes and delays. Research showed that a large proportion of crash fatalities are related to inadequate roadway conditions. However, the safety performance function of Highway Safety Manual has not included the roadway features yet. This study aims to develop enhanced SPF for highways in Oklahoma and then explore how the crashes can be decreased from the roadway conditions aspect. 4 datasets were provided by OTRD for this research. Safety database with crash data, SKID study program with friction data, PMS datasets with condition data, and site manager dataset with construction and maintenance record. The team spent extensive efforts on linking and filtering the 4 datasets thanks to the differences in the data format, especially the location and interval. About 1,800 segments were filtered out for building up an enhanced SPF. The independent factors covered crash exposure, surface conditions, and geometry factors. Enhanced SPF based on negative binomial model is built and validated with good prediction performance. The modeling results reveals that pavement friction has significant influences on the rate of crashes. The question comes to how to consider pavement friction in decision making. First, determine the demand. Following the method 3 in the OSHA guide for pavement friction, the investigatory level is recommended at 35, while intervention level at 30. Second, find the contributors. The results of statistical friction prediction model indicate that the air voids content and the percentage of fine aggregates have significant effect on the pavement friction. Third, compare the friction performance of pavement after each kind of treatment. It is observed that different treatment results to different friction performance. The aggregate type and the micro-devel property of aggregate deserve more attention in pavement maintenance. Finally, it is of great interest to consider life cycle cost in decision making. By setting up the deterioration model for each treatment, 3 alternatives were compared in a virtual example project to maintain the friction level above the investigatory level. It is observed that the high friction surface in treatment changes from the most expensive one to the cheapest one when considering the delays caused by crash. Conclusions of this study are summarized, and a special thanks gives to ODOT for their sponsor and technical support.
And finally, our first place winner this year for our OTRD 2020 goes to another research team from Oklahoma State University, studying the project entitled Characterizing Behavior of Steel Axial Lap Connections with Bolts and Welds in Combination. let's look at this final video.
Hey, my name is Caleb Bennett, and today I'm going to be showing you my research at Oklahoma State University. Let's go. Once again, my name is Caleb Bennett, and I'm a master's student and graduate research assistant here at Oklahoma State University for Dr. Simon. My research consists of monotonic loading of single shear axial lap connections and fatigue testing of double shear axial lap connections. In the previous months, we've done testing, monotonic testing, on single shear specimens in the frame that you see behind me right now. Currently, we're testing fatigue on double shear connections, which is what you see in the frame behind me right now. In this video, I'm going to take you through the specimens, some of the results we have from single shear testing, and some conclusions that we have that are beneficial to the bridge industry. Once again, if you're not familiar with our connections, the difference here is that we call them combination connections. That means the connection employs bolts and welds together to share the load. Next, we're going to take a look at the specimens. First off, we have the single shear specimen sitting right here. It's a Class B specimen. The upper portion is only for the grip. The lower portion is the portion we're actually testing and recording data. We've completed 12 tests on this single shear as of today. Next, we have the fatigue specimen. This is a Class A fatigue specimen. We're going to run 6 tests under fatigue loading on this specimen here. We're going to have a 2x2 and a 2x2 on the upper and the lower with the same size weld, so we near the connection on both sides. That way, whenever a failure occurs, we know that it's going to be the same 2x2 connection with the same bolt to weld ratio. And then here, we're going to do the same process, but with a Class B splice plate. Now let's get to the fun part, the actual testing. So, what you're watching now in these 2 videos is a view of a single shear combination test. That's a test with bolts and welds. As the test is running, you can see that the plate starts to bend and that the weld eventually fractures, which causes the failure of our connection. This video is sped up. The actual test took 45 minutes, but this stuff is so cool. These single shear tests were great. They show that the combination connection does possess a higher ductility, capacity, and stiffness in comparison to the bolted and welded only tests. Now, what's left? We're testing fatigue. This fatigue is going to be great. We're going to try to categorize the combination connection on the SN curve to make everything easier for bridge designers in the future and keep the public safe. Thank you for watching my video.
So, congratulations to the winners. Thank you to everybody who took the time to put one together for us. Thank you for your efforts. I do hope that the participants today and auxiliary participants that might not have a chance to join us today, but later, will have the chance to go back through and look at these videos, look at the posters, gather some information, and find those little nuggets that we can incorporate into what we're trying to get done, which is make our transportation system better. With that, again, I will say thank you for hanging in there with me. We now are set up to have a break period, so go gather some lunch, maybe take care of a few phone calls or some emails, but hopefully you'll have a chance to go to our web pages that do have the posters and our demonstration videos. Those links are noted on pages 9 and 11 of the program. I'm assuming most of you have the program. If you don't, put a Q&A out there and we'll make sure we get the program to you. And with that, I guess I will ask, I don't know if there's any questions or anything out there. I think we had something maybe set up to put the link out there in the Q&A. Trace, I'm going to call on you to see if there's anything out there.
I see no questions at this time.
Okay. Okay. So with that, free to go to lunch. I think we're going to have maybe a countdown timer something up, or a countdown timer or something up. But during this break, if you have some questions, dump them in there. where we will get to every question at some point. May not be able to get to them all today, but we will get back to you no matter what. So let me stop my share. I'll come back now in front of you and say, with that, I guess I'm going to release this for lunch. Dr. Molina, if there's anything else you need to do, please chime in.